Hello again, this is Roy Niswonger from MotleyPixel.com. Today I'm going to show you my do-it-yourself time-lapse turntable. Become very interested in time-lapse photography, and I know the linear rail systems, dolly rail systems, are very attractive to incorporate some linear, smooth foreground movement relative to subjects in frame. They are quite expensive turnkey out of the box, but I am considering a do-it-yourself for that. This particular build is much more affordable. It's going to offer the user to mount a camera on a tripod head of choice onto this gearbox powered by a small 12-volt battery to get a rotational effect time-lapse or turntable time-lapse. So I did some searching on the net. No one's really built many of these, if any at all. There are some quasi setups with astronomy gear, but this one here is a very small footprint, relatively lightweight, and I think it's going to do the trick. Let's start with the components. The key component here that I found at servocity.com is their worm drive gearbox vertical shaft, and it's this guy right here. This is the motor. It doesn't come with the motor. This is the worm, this is the gear, 3/8" gear shaft. This is a 30-to-1 gear ratio. So every 30 rotations of the worm, you're going to get 1 rotation of the output shaft. So in 30 minutes, you'll get 1 rotation at 1 RPM. Okay? If you can vary the speed, which I'll show later, you can. If you can bring this down to 0.5 RPM, you can get a full revolution in 1 hour, which may be more attractive for a full landscape 360 rotational time-lapse capture. This particular guy here is from Servo City. The part number is W as in whiskey, D as in Delta, G as in golf, 30, P as in Papa. It's a $60 part. The motor is a 1 RPM DC 3 to 12 volt DC gear motor, and it is $25. Its part number is R as in Romeo, Z as in Zebra 12-3000-1 RPM. Okay, so I assembled the motor to the gearbox. I also soldered power to the terminals. This is also a boot that you can order. It's a rubber cap to protect the end, and you can find that on the product page as an accessory to the DC gear motor, which I highly recommend ordering to keep the elements off the contacts and such. Moving on to the base, I mounted this to a 1/2" 4x5 aluminum plate. Now it's a little overkill. I spent a lot of time drilling out all these holes. I did reduce the weight by about 35%, but it's not that heavy. It is aluminum. Okay, I did use drills, I did use taps. These machine screws are tapped into the aluminum here to hold them in. Now what I did underneath here, because this is going to mount onto a tripod, I put 2 locations for 1/4-20 tripod screws for quick release plates, say for instance. Notice here that you can see that it looks like an insert, and that's in fact what it is. You can tap this aluminum 1/4x20, but don't count on the aluminum threads lasting very long. So I picked up these inserts. They're called Keenserts, Keenserts. They're 1/4-20 inside. The outside, I forgot what the thread is, but basically you tap that, you screw in the Keensert, and there are 2 legs, 2 tangs that protrude outward, and you tap them into the side and they lock these 1/4-20 inserts. And then ultimately what you're going to have here, you have a tripod quick release plate, and you're going to screw that on as such, okay, and then that's going to mount to your tripod. I also bought a bullet level indicator here, and just drilled that in and epoxied that in just for level indications not needed. Okay, moving on to the next component, we have the upper plate, in which will be mounted onto the 3/8" output shaft of the gearbox. Okay, and this, I forgot the dimensions, it looks like about 6x6 roughly. This is a 1/4 inch 6061 aluminum. Drilled out a lot of holes to save weight. I could have gone overboard here with the aluminum and the strength. There are various materials you can use, so stick with your imagination. This was kind of ad hoc engineering. I have a good metal supply shop. This plate was only about $4. The 1/2 inch was $7. Anyhow, I used a piece of aluminum stock here to raise this ball head up. You know, just use your imagination again. The reason why I did that is because the lever here needs to clear the plate. Also, when your camera's mounted at the top here, you're going to have things hooked up to the camera, and all the things hooked up to the camera must rotate with the camera. So if you don't, you're going to get some entanglement and such. I would recommend a nice little footprint here if you can. Again, this is about 6 or 7 inches by 6 or 7 inches. The intervalometer set up here, you can tie it down with Velcro or tie, zip tie, or even a twist tie. Underneath is the collar for the output shaft of the gearbox, and let me get you that part number here. It's a 3/8 inch bore aluminum hub. It's $5. It comes with the mounting hardware and the set screw for the shaft. The part number there is 3468H as in hotel. Okay, now onto the power system to drive the motor, which drives the gearbox. Now, you can use various voltage sources here. Again, this is a 3 volt to 12 volt, but it's a 1 RPM motor rated at 12 volts DC. So if you supply 12 volts, it should rotate within tolerance at 1 RPM. I decided this is not going to be the final battery pack. This is a lithium polymer RC, radio controlled hobby pack. It's 3-cell lithium polymer. It's about right at 12 volts, nominally 11.1 volts, but 12 volts DC at no load. Okay. You can take this battery and hook it up directly to the motor, and it will rotate it close to 1 RPM, period. Or you can opt to incorporate a device such as this, and there are many out there. This is basically a digital PWM, pulse width modulation speed controller. So basically you hook up the power source, you hook up the motor, and